Hi, this is Matt in Gardens by the Bay in Singapore. The topic of this video is estimates. How to calculate estimates in various situations. Those situations could be software development, risk, or process improvement. If you look at those three professions, software developer, portfolio manager in an investment bank, or process consultant for process efficiency, what do all those professions have in common? Well, the common point is that they're all going to have to, they're all going to have to make decisions based on estimates and based on calculations. So of course, you could make those decisions based on human intuition, which is fine, it works as well. But there are a lot of situations where it turns out that simple calculations outperform human intuition. So for instance, the software developer is going to decide whether or not he should start a project based on how long he estimates the project to take. A portfolio manager is going to decide on an investment based on a risk-return ratio, so it's going to work out whether the investment is worth it or not. The consultant for process efficiency is going to decide whether it's worth implementing a change, whether the savings impact is worth the change. So all those decisions, they're going to be based on estimates. And those estimates they could be based on gut feelings, experience, or they could be based on calculations following a particular rationale. There is nothing wrong with going for the path of human intuition. That works. So you could always rely on experience and gut feelings. That works to a certain extent. But there are a lot of situations where making simple calculations outperform human intuition. So the thing is that many times the calculations do not seem straightforward. It doesn't seem easy to make those calculations. There is a very interesting book called How to Measure Anything by Douglas Hubbard that precisely gives plenty of practical tips about how to make calculations in all the situations where it's not straightforward at all. There are a bunch of tools to help you with those measurements. We're going to see three: decomposition, confidence intervals, and Monte-Carlo simulations. So calculating estimates and making those measurements can be, in some situations, relatively easy. So for instance, for process improvement, that can be usually quite straightforward. If you take the example of a cupcake factory, where the factory workers are preparing cupcakes, and then you want to improve this process, and you want to calculate how long each step takes. And in particular, you want to check how long it takes to prepare the dough for the cupcakes. So it's not very complicated. What you can do is just go to the floor and then effectively measure how long it takes for the factory employees to prepare the dough. And then if you want to calculate the total amount of time spent on preparing dough for a whole day for the whole factory, it is an easy, the model is easy, it's just a simple multiplication. So getting the input data is easy, working out the model is easy, that's fairly straightforward. Now, where it gets trickier is in a situation where you cannot simply go to the factory floor and then take the measurement yourself. So there are situations where it's just not possible, or it's not practical, or you don't have time. So what you do is that instead you rely on expert estimates. So you're going to go and talk to the factory workers, you're going to sit down with them, and you can ask them, so how long do you reckon it takes to prepare dough as part of the process of making cupcakes? And of course, if you start doing this, then there is an element of uncertainty. And this can be an issue, because now instead of actually going to the floor and taking the measurements, you have to rely on something that's provided by human beings. So it's going to be a mix of gut feelings and experience. And you need to factor in that uncertainty. You can't just use that as an exact figure the same way you would use a measurement. So how do you do this? Well, one way of doing it, and it's an idea that's inside this book, How to Measure Anything, what you can do is, instead of asking for a single value, you ask for a confidence interval. So you go and say, could you please give me the interval where you're absolutely sure your value is? So you're going to tell me how long it takes to prepare the dough of the cupcakes. Do you reckon, are you 90% sure it's somewhere between 5 minutes and 10 minutes? And then they're going to say, oh yeah, it's definitely between 5 minutes and 10 minutes. So what you get is a 90% confidence interval. Instead of having a single value, you have a 90% confidence interval. All right, so that's nice and well, but now what do you do with that 90% confidence interval? How do you compute it inside your model? Because you've got a model that allows you to calculate the total amount of time it takes to prepare dough as part of the cupcake process. You want to calculate this for the entire factory for an entire day. Okay, so you've got a very simple model to calculate this. It's just a series of multiplications. But then now your input is not a single value anymore. It's a confidence interval. So how do you do it? So you think, okay, I've got an interval. It's fine. Maybe what I could do is just so I've got my interval is somewhere between 5 minutes and 10 minutes. So okay, what I could do is just take the average, 7.5 minutes, and I feed that into my model. Yeah, you could do that, but if you do that, you're actually still losing something out. It's not quite correct. Doing this is not quite correct. So what do you do then? What's the solution? Well, one solution is to use a method used by finance institutions when they calculate option prices, for instance. It's a Monte-Carlo simulation. So this sounds like it needs a lot of computing power, and it does when you do that at an industrial scale. But for simple estimates, you can just do that with a simple Excel spreadsheet. It is possible. It's fully simple. So what do you do? How does it work? How do you do a Monte Carlo simulation? Well, your 90% confidence interval, this is going to be a probability distribution. And this probability distribution is going to be used to take a draw. You're going to have a system that takes a value at random from this distribution and feed it into your model. So you can, the spreadsheet is going to draw a value somewhere between the confidence interval, between 5 minutes and 10 minutes, feed it to the model, and you're going to have several runs. After you run it for a number of runs, you obtain a series of results with a frequency for each result, and this is a new probability distribution. Okay, so what do I do with that probability distribution? At the end of the day, people are interested in only one result, only one value. So how do I calculate the resulting value? Well, the resulting value is where you do what you usually do when you've got a probability distribution. So you're going to calculate the expected value of the distribution, and this is simply the probability weighted average of the distribution. So that's it. This is a way of doing it. Now the thing that is key is that the purpose of those calculations is not to obtain an accurate representation of the future. The purpose is not to predict the future, because that's impossible. What you want to do is simply get a measurement that helps you make a decision in a way that's better than human intuition. That's it. All you're competing against is human intuition. You're not aiming for accuracy. This is aiming too high. You're just aiming for better than human intuition. Okay, so this is the end of this video. In summary, how do you do it? So in summary, how do you do estimates? Well, 3 tools that you can use. Yeah, thank you. Number 1, decomposition. This is when you can't take measurements directly, so you're going to break down your measurement into individual components that you can measure. And you're going to use a simple decomposition model to calculate your final value. When you cannot take measurements at all, what you're going to do is you're going to rely on expert estimates. You're going to ask experts to give you rough guesses in the form of intervals, 90% confidence intervals. And then how do you use those intervals back into your decomposition model? Well, this is where you're going to use Monte Carlo simulations. And what you can see behind me is about the fireworks for the 50th National Day in Singapore.